Assalamualaikum and hi. My name is Seri Sofia binti Nazri with matric number 73822. So I'm going to demonstrate a narrated video about the atomic species balance and extent of reaction method analysis. Based on the question given, there are two balanced chemical reactions. The first one is when ethylene reacts with steam to produce desired product of ethanol, and the second one is ethanol further reacts to produce undesired product of diethyl ether. There are also the flow chart of the process with unknown input variables. Meanwhile, there are the composition of the product gas is given with a basis of 100 mol of effluent gas. Next, degree of freedom analysis using different method. So the first method is by using atomic species balance method. So as we know, there are three unknown label variables at the input side, with minus with two independent atomic species balance, which is carbon and hydrogen, minus with one molecular balance on independent non-reactive species, which is the inert gas, and minus there are zero other equation relating unknown variables. So the answer is equals to 0, which is solvable. Meanwhile, for the other method is by using extent of reaction method. So first of all, the same as the previous method, there are three unknown label variables plus with two independent reactions since there are two chemical equations, and minus with four independent reactive species, minus one independent non-reactive species, and there are also no other equation relating unknown variables. So the answer is equals to 0, which means solvable. Next, we can calculate the reactor feed detail, which is the unknown labeled variable just now at the input stream, by using the atomic species balance. So first, we need to calculate the number of mole of ethylene C2H4 by using carbon balance. So basically the formula is input equals to the output. So at the input, we don't know the number of mole of ethylene times with the 2 mole of carbon in 1 mole of ethylene equals to the 37.4 mole of ethylene at the output side times with 2 mole of carbon present in 1 mole of ethylene plus with 4.5 mole of ethanol times with 2 mole of carbon present in 1 mole of ethanol and plus with 0.2 mole of diethyl ether times with 4 mole of carbon present in 1 mole of diethyl ether. So we calculate it, simplify, and we got the answer 42.3 mole of ethylene at the input side. Moving on to the next unknown variable, which is we need to calculate the number of mole of H2O. So we need to use the hydrogen balance, or we can also use the oxygen balance. It's going to produce the same answer. So here I'm going to use the hydrogen balance. So at the input stream, we want to calculate the number of mole of H2O times with 2 mole of hydrogen present in 1 mole of H2O plus with 42.3 mole of ethylene just now that we calculated previously times with 4 mole of hydrogen present in 1 mole of ethylene equals to the all of the elements that have hydrogen in it at the output stream, which is 37.4 mole of ethylene times with 4 mole hydrogen present in 1 mole of ethylene plus 4.5 mole of ethanol times 10 mole of hydrogen present in 1 mole of ethanol plus 0.2 mole of diethyl ether times with 10 mole of hydrogen present in 1 mole of diethyl ether, and lastly plus with 46.6 mole of H2O times 2 mole of hydrogen present in 1 mole of H2O. So we calculate it, simplify, and we get the answer. Number of mole of H2O present in the input stream is equals to 51.3 mole. Okay, lastly, for the number of mole of inert gas, so inert gas is non-reactive, hence input is going to be equivalent to the output. So inert gas 0.113 mole inert gas as given in the question times with the basis 100 mole basis, so we get the answer is 11.3 mole of the inert gas. Next, we can also calculate the unknown label variable just now by using other method. So for this time, we're going to use extent of reaction method by using the formula of Ni, which means the output stream equals to Ni naught, which means the input stream plus the stoichiometry. So we're going to look at the ethylene first. So as we know, given in the equation, there are 0.374 mole of ethylene times with the 100 mole basis. So we are done with the Ni equals to Ni naught. Ni naught is the number of mole of C2H4 ethylene that we're going to find later, minus with Z1. Minus is because the ethylene is reactants. Reactants at the chemical equation 1. Okay. And the coefficient of ethylene is also 1 mole. So that's why it is negative 1 Z1. And there are also no ethylene at the second chemical equation. So there are no Z1 here. So we simplify it and we get the first equation. So we denote it as equation 1. So next we're going to look at the hydrogen. H2O. Sorry, H2O. Okay, so as we know, there are 0.466 mole of H2O at the output stream times with 100 mole of basis. So we're done with the Ni equals to the NH2O, and I note the Ni naught is NH2O that we're going to find later, minus with Z1 plus Z2. This is because at the first chemical equation, the H2O is the reactant, and that's why it is negative, and the coefficient of the H2O is 1, so that's why it is negative 1. Okay, and Z1 represent that the H2O is at the chemical reaction 1. Okay, plus Z2. Z2 is because it is plus because H2O at the second chemical reaction is at the product side. Okay, so we simplify and we get the equation 2 for NH2O. So next we're going to look at the ethanol. So as we know, there are 0.045 mole of ethanol times with 100 mole basis equals to 0. Why 0? 0 is because 0 is Ni naught, is it? So Ni naught is the input. So there are no ethanol added into the reactor. So that's why it is 0. Plus with Z1. Z1 because at the chemical reaction 1, it is the product of the reaction, so it is plus Z1 minus 2. Why 2? Because at the second chemical reaction, there are 2 mole of ethanol, okay, as a reactant, so that's why it is negative. Okay, so simplify, we get the third equation. Okay, next is for the diethyl ether. So it's given in the equation there are 0.002 mole of diethyl ether times with the 100 mole basis. So we equals to the 0, also 0, because there are no diethyl ether being added into the reactor. So that's why we don't have any input of the diethyl ether. That's why it is 0. Plus with Z2. Plus because it is the product, Z2 because it's happening at the second chemical reaction. So we got the Z2 equals to 0.2 mole. Okay, next what we're going to do is we just substitute Z2 equals to 0.2 mole into the equation 3 just now. So we substitute the Z2 into the equation and we get Z1 equals to 4.9 mole. Next, we substitute the Z1 equals to 4.9 mole into equation 1 just now, and we calculate and simplify, we get the answer for number of mole of C2H4 equals to 42.3 mole. It is the same as previous method, okay? So lastly, you substitute the Z1 and Z2 into equation 2. So we get the number of mole of H2O equals to 51.3 mole. It is also the same as the previous method. Okay. So that's all from me. Thank you.